Hey all, I'm Karthik. I initially named this Go Beyond Gatekeeping, but as I was building the slides, I realized there's a better name, which is Lessons from Scaling Security Teams. And much of this keynote is going to be a story of how I stumbled upon these lessons and some examples along the way. So about me, I am Karthik Nagarajan. I lead the product and platform security team at OpenAI. I've been doing the security thing for a little over a decade, mostly at startups, high growth ones. My most recent stint was at Robinhood for 5.5 years. I was the first security engineer, built out the security, privacy, trust, and safety, parts of fraud. It was a fun ride. Now, for the last 7 months or so, I've been at OpenAI, building product and platform security. This talk, unfortunately, isn't going to be about LLM and AI security. I will be speaking about LLMs a little bit at the end, but not much about the security concepts around it. I will be using a lot of DALL-E. On the right, actually, me and my dog. On the left, DALL-E's interpretation of me and my dog. So you'll see a lot of DALL-E generated images here. Let's jump right in. This statement here should not be new to anyone. I'm sure everyone here agrees with it, especially in the cloud era, right? Build guardrails, not gates. Don't get in the way of people, especially in high growth companies. You don't want to stand in the way of people doing things. You want to move fast. You want to iterate. You want to get the product out to the customers as soon as possible. And, coming in and joining a startup, I always wondered, what does that mean? How do I do this? So I took the first hypothesis. I was like, hey, I'm just going to get in super early. And I'm just going to inject my security requirements at the product requirement stage. You're building a product. You're telling me what you're going to build. And I'm going to say, great, if you build these security requirements in, it's going to be magical and it's just going to work and everything will be fine. Users will be happy. Your product will be secure. I will be happy. Everything will work. Let's go. The thing I realized along the way, though, is that that's not quite how startups work or any really fast moving companies. Requirements change. The thing that presented to me looked like these really nice pipes with straight lines, no weird edges, no cracks. It just great. The thing that eventually got built based on customer feedback, technical constraints, integration constraints, whatever it might be, ended up looking like the thing at the right. Kind of cracked pipes, weird edges coming all over the place, water flowing, weird interfaces. And so I stumbled upon my first lesson. I can't actually drive security by doing requirements engineering. It's not as effective, especially at a company where everything changes almost every day. And you can't just lean on, here's how I want to do things. You have to be able to adapt. You have to be able to adapt to ground reality. And you have to be there when the changes happen so that you can guide it accordingly. And I have an example for this. So early on, there was a team that came to me and said, hey, we need to receive these super sensitive files from customers on this customer service portal that we have. I said, yeah, that sounds fine. What do you need to do? They said, oh, they need to upload their IDs and their bank statements and stuff like that. We need to download it and we need to send it to our internal administrative thing. It's like, yeah, sounds great. All you need to do is use this secure thing that we've done, the secure portal. Customers will upload it to that. Everything will be encrypted end to end. And you just have to shift it over to your portal. It should all be automatic, streamlined. They said, great. They were happy. I was happy. I walked away from the conversation. They built it in the next 2 weeks or so. I checked in a couple of weeks later. I was like, hey, how's this going? I said, oh, yeah, it's great. Oh, except we couldn't actually figure out the part between getting the customer to upload into the secure portal and us uploading to our internal system. So what actually happens is that the customer support reps, they download all of these documents onto their computer, and then they upload to the secure portal. I was like, wait, so you're saying all customer documents are now sitting on this laptop? They're like, yeah, that's fine. They immediately send it to the portal and they delete it immediately. I was like, yeah, that's exactly the thing I was trying to avoid, actually, which is all of these documents lying in plain text somewhere. So I went in with these really clean set of requirements. Turns out they couldn't figure out the integration pieces, so they skipped the critical part and ended up with this chasm in the middle of this really nice bridge that we were building. And they were all good intentions. They were just trying to get stuff done. So my understanding, my lesson from all of this was, oh, I can't just tell them, oh, here, do it this way, and it just works. I have to do something more. And so my next hypothesis, and again, everyone in this room agrees with this, let's just build paved paths and make them secure. If we build these clean paths and we say, it goes to this really nice, secure place, it's easy to use, it's easy to follow, it has great interfaces, people will use it. And the way I went about this was, I said, let's fix the riskiest problems first. Authentication, authorization, access management, whatever it might be. It depends on your company. And let's iterate quickly. Let's iterate at the speed of the company. Let's validate on services that we may be running. And once we have validated it and it works for our threat model, let's deploy that to product teams. And let's use demo days, lunch and learns, memes, whatever works at your company. And let's get it out. And if you need to make PRs, make the changes yourself, get it into prod. That's the thing that matters. And we were all excited about it. We said, yes, this is going to work. Except when it didn't. The beautiful place still existed. We could still get there, except the path wasn't as clean as we thought it would be. It was this really curvy, windy road with like potholes in the middle. And the reason was very simple. We would deploy something weird would go wrong. Either it didn't scale, or we didn't understand their workflow well enough, so we were slowing them down significantly. Or it worked, it was all fine, but we were inundating our own logging systems or monitoring systems or whatever it might be. And so it just became unpleasant to use, and it got in the way of us doing our work well. It got in the way of our partners doing their work well. And while the whole thing was about gaining trust, we said, hey, if we do this correctly, if we get them to do it, they'll gain trust. And to a certain extent, we did. It's like, oh, this is great. You've thought about this. We ended up losing trust because we had to get them to take time off the work they were doing, deploy the stuff that we wrote. And then it didn't work. And then they had to fix the stuff that we wrote. It was just not great. And so the lesson I learned, I wasn't my customer yet. I didn't quite know what my customers' workflows were. Sure, I ran internal services. We built our own software. We did our own thing. But we weren't running at production scale. We didn't quite have the same tooling. Like, we were building detection and response systems. We were building access management systems. We weren't building stuff for customers. So that was my lesson. I'm not my customer yet. And so what if I became my customer? What if I built production services? What if I said, hey, what are some critical security-specific services that you need for your product? Do you need authentication, authorization? Yeah, we're good at that. We're experts at that. Do you need cryptography? I got cryptographers on the team. We can manage this stuff for you. And so we said, great, we're going to run production services now. We're going to hire stellar software engineers on the team, and we're going to own the stuff. We're also going to build paved paths because they have to go together. You build the paved paths, you build the production services, they all go hand in hand, and you dogfood your own stuff. So you're running a high-scale service. It's at the edge. It's receiving a lot of traffic. It's gating a lot of traffic to your other services. And if it works for you, if it's working at scale for you, there's no doubt it's going to work for others too, right? And people are going to trust you because, oh, you put it in your own software? That's amazing. If it's working at your scale, it should work at our scale. Oh, you're using the same monorepo. You're using the same Kubernetes infrastructure. You're using all of the same paradigms. Amazing. It just works off the bat. Increased trust. Partners don't have to do that much more. They just, it's a plug and play. It's right there. We've already figured out the scaling problems. We've figured out the interfaces. We've figured out the monitoring, logging, all of that stuff. They're like, amazing. Okay, great, we're done. Security solved. Let's just all go home. You just hit a scaling point. You hit hypergrowth. There's a Y curve. Maybe you found product market fit. Maybe the internet loves you, or maybe they hate you, or maybe all of it at once and Reddit is just going nuts for you. May or may not have happened to me. Now, everything's kind of running hot. All of your Nginx servers are running at 95%. Your EC2 is reporting that it's about to fall apart. You're on call with SREs, and they're like, "We're out of capacity. You need to do something now." Like, yeah, great. No, we're working on it. Also, people were really interested in what your security posture is and how well you're protecting your systems. So you need to do that too. So you're scaling services, you're seeing increased attacks, things are weird. There's a DDoS happening somewhere for fun. And while all of this is happening, you need to figure out how to scale, how to do it fast, and you had to do it with the same set of people that you had yesterday when this wasn't a thing. It gets pretty tricky. And so you go to your partners. You're like, "Hey, I really need to borrow your people. Please let me borrow your people." You go directly to the ICs that you have a relationship with. "Hey, can you please help me fix this? Like, this is bad." And they're going to give them to you because you're at the edge, right? Like, you're a critical service. They don't want you to go down. That affects them too. So they're like, "Yeah, whatever you need, please take it." But you end up losing some trust, losing some points because they have to reprioritize now because their services are running hot too. So they have to reprioritize. They have to sort of say, "Oh, great, yeah, this person's helped us so far. Let's just get them going." At the same time, you're like, "I really need to scale up my team." You go negotiate with finance. You tell them, "Hey, I need to double my team like quickly." And finance looks at you, they're like, "You're already a large team. Industry ratios are X, and we've benchmarked, and you're well past the benchmarks." And you try to explain, "Oh no, we're a novel team. We're doing something new. We're building product. We're building systems. We're building internal software. We're building a red team. We're doing everything." And it's a little late in the game for that. You should have explained this a while ago to them, and they should have bought in. They should have given you the headcount already, not when everything's melting. And even if you had to explain all of it, it's really difficult to double quickly, no matter at what scale you are or how popular you are. So you just end up with heroes. You have a small set of people, and they come out of the woodworks because you hired stellar engineers. You hired really motivated, strong people, and they care about the work they did. They wanted to stay up. They want their software to stay up. They want their systems to stay up. And they're not going to let it go down. So they do long nights, long hours, long days, whatever it takes. And heroism isn't a good thing. Heroes burn out. And then you run into another problem. Who is overseeing these heroes? Who is overseeing you as you build this software? You already have a team that's stretched pretty thin. And because that team is stretched thin, you're probably pressing the bypass button every single time to build a software you're building because you're like, "Oh, we're security experts too. We don't have to go through the same SDLC review process and all of that everyone else does. Let's just press the easy button. Let's just go to the end state because we're experts. We got this." That's problematic. And for me, the lesson here was I was already running a critical service. I was securing the firm. I was providing security for all of the things that we were doing. And it's really hard to manage risk, provide oversight, build and build critical services all at the same time. You can't do it without a very large and very confused team. And so, okay, you can't do it all. So how did this play out for me? It played out in really interesting ways. In peacetime, it was all beautiful. Everything was amazing. All the services worked smoothly. People loved working with us. It was great. And then we had a scaling point. And the central services that we built, there was one service actually that we built for managing all of our secret stores and things like that. And this actually ties into my paved pods example also, that And I decided to wait until now to give you both. When we were building paved paths, one of the things that we built was we said, hey, there's this application that needs to encrypt secrets as part of their application flow. And we're just going to give them this library that does it. And this library is going to depend on HashiCorp Vault, transit encryption. It's fast, it just works, there's no latency, it's amazing. And it actually really worked until we hit the scaling point, at which time we just started seeing deploys failing. We couldn't scale up fast enough. Kubernetes was just complaining that it couldn't get secrets. We're all like, what is happening? Why is this happening? Why is latency so high? And we realized we ended up mixing the application control plane and the data control plane. We were using HashiCorp Vault for managing application level secrets and deployment level secrets. And along the way, we also used it to manage data plane secrets. Now, we could have, of course, set up a different HashiCorp Vault. We could have done all of those things, but we didn't. We discovered this when everything was kind of failing. And the reason we did that was because we had this other central service that we were running, this critical service, that was also hitting its scaling point. The database was filling up, latency was high, and everything was running in really weird ways. So we said, oh, let's just do both of these at the same time. We ended up hitting a scaling point for both. Things ended up getting weird. The bigger problem was these things, core encryption critical service things, they weren't the most securely designed services. When we eventually brought in a red team and we gave them the objective of find us our crown jewels and find a way to get into it, the first thing they did was go after these security critical services that we built and found a path to compromise them, which kind of sucked. So if you're running a critical service, which is securing the firm, you can't also run production services. It's just hard to carry that many pagers. And you can't oversee yourself. You've just created infinite recursion, things just get weird and not enough on it. And so I built this team. I eventually gave it up to a great CISO. I walked away, became an IC again, spent a bunch of time doing other things, and eventually had this insight. What if I treated org building and program building like I treat how I build any other systems? What if it was a system design problem? And what if we try to do this by using leverage and staying lean? What if it wasn't hire as many people as we can? Instead, hire as few people as we need to, hire high leverage people, and reduce communication overhead and planning overhead and coordination overhead. And this is all backed by this long-held conviction, which is the way to reduce security risk is to reduce cultural risk and behavioral risk. If you can give humans, and if you can give systems secure by default design, you can give humans secure by default choices too. If humans make fewer choices, if they have to make fewer choices that are insecure, they will create less risk. So what does that mean? Again, the core hypothesis, everything is secure, everything is built consciously, but what is a well-designed system? I think this is what we mean by cloud native, just so that we're all on the same page. This is a cloud native system. Sorry, that was a bad joke. Well-designed systems, they're resilient, they scale, they're predictable, they have clean interfaces, they have rigor going into them, and they fail in predictable ways. They will tell you very, very early if they're going to fail. And they evoke trust because they have these strong interfaces, because they have clean lines, they evoke trust, and they're easy to use. But before we go into the program building and building this product team, platform team, whatever you want, we need to make sure there's the basics. You're building a security program, identify your crown jewels, find your non-negotiable risks, your existential risks that need to be mitigated, and build a foundational team. And these could be generalist security engineers, platform security engineers, application security engineers, detection and response people, whatever your org needs. This mic's about to fall off, sorry. Whatever your org needs. Build expertise, build the base team, hire stellar people. but build sparingly. Don't hire too many people, build just people you need. And this is a lesson I learned also, which is avoid hiring architect astronauts. What do I mean by that? Every company needs architects. Every company needs these very senior people that are going to help you scale to the next level, build the next generation systems. But if you hire them too early, you run the risk of them not being connected to ground reality. And at this stage, at the very early stage, you need people that are in the trenches with you, that understand the trade-offs that need to be made, that understand what's going to go bump at night. So early on, avoid architect astronauts. Okay, so now you're ready. Your products are getting underway. Your product team's asking for a lot of help. I started by hiring a security partner or two, depending on your need. And this is an in the trenches person. This isn't a consulting role. They're sitting with the team. They're going to understand everything the team does. And so for this, you need somebody with a lot of depth in security and scaling. Former software engineers, current software engineers, people that have built security systems in the past. All of these are super valuable people to have. Once you have this person in place, you also want to hire a software engineer. And this is not a software engineer that's going to build internal tools for you. This is a software engineer that is going to build production systems. Yeah, I know I said don't build production systems. I'll get to this in a second. You want somebody that has the ability to build production systems. These two people together, they're going to be your highest points of leverage. So first thing you do, you hire a security partner and you embed them into a product. Whichever product you think carries the most risk for you or is moving too fast or any number of things. And depending on your working situations, if you're remote, they're in the same Hangouts or Zoom meetings or whatever. If you're in the office, they're sitting in the same pods. They're living, breathing, working alongside the team to support. They understand their problems. They have as much context into this as anybody working on the problem. And they act as a direct security interface to this team. They start collecting the main problems to see, making a list, and they keep telling you, hey, this is a problem we need to fix, this is a problem we need to fix. And now you deploy your software engineers. You've identified some problems. You've successfully hired some of your SWEs. You've identified some problems. If you don't have the right resources in your partner teams, they're heads down building products. And so you write a rules of engagement. And what is a rules of engagement in this case? It's very simple. You just define the problem, you define the scope of the problem, you define what a good end state looks like, and you put a time box on it. You establish clear goals, you establish handoffs, and this is most important, you identify the people on your partner team that will take this forward once this is done. This isn't a you build this forever situation. This is I'm deploying a resource to help you get off the ground situation. And while the software engineer is on the team building this cool stuff, they identify paved path opportunities for you. Maybe they're solving the same problem again and again. Maybe they're building golden images again and again. Maybe they're using the same auth libraries again and again in weird ways. And they say, hey, if we solve this, we can actually help a lot of other teams. And so you build some of these paved paths. And you have this embedded suite, they can just deploy this paved path for you, and they can tell you what's working, what isn't working, how is it breaking. And you have this really tight feedback loop that you can just use to adapt and build the right thing for everyone else. And doing this helps you build trust with the teams. You said, hey, I need you to do X. And your partner said, I can't, I don't have the people for it. They said, don't worry, I have the people for it. I have a really senior person, and I'm just going to give them to you for free for the next 2 months or 3 months or however long it is. And they're going to give you high quality code. They're going to help you maintain your timelines, and they're going to help you ship. For you, you're learning what you need to invest in. You're learning what the workflows that your partners use are. You're learning where to deploy your resources next. And you're using it to create secure libraries, secure systems, detection and response pipelines, whatever it may be. There's a few important things here. I mentioned the rules of engagement already. It's really critical that you write this and you follow this. This is a high trust operation. You're giving one of your senior resources away for the next 2 or 3 months to a partner team, and you're trusting them to give them back to you at the end of it after seeing how absurdly competent they are. And that requires trust. It requires trust on both sides because they are trusting you to give this resource to them until the job is done. Because this is your most valuable resource, right? Or at least that's how you're presenting it. What's stopping you from taking them away when the next critical thing comes along? And so when you write your rules of engagement, be crisp about it. There are no escape hatches unless the product is, the product stops building or, something fails. There are no escape hatches. There's no early termination. There's no, oh, I need this person for this other project, I'm going to take them away. No. You finish what you're doing. You ship. And then, and only then, you take them away, and you need to create some periods of non-embedded time. You can't just ship engineers from team to team. They're going to get burned out. They're going to get frustrated. And you're not going to have a cohesive team because, they're all working on different things. So you need to create periods of non-embedding so that they can work with your other team members. They can do some research. They can just take a breather and do some fun things. Maybe they build an internal tool. Maybe they build a paved. Whatever it is, it doesn't really matter as long as you both agree on what it is. And the most important thing is to always seek the embedding that gives you the highest leverage. And this changes. This changes throughout the life cycle of the company. You are an early stage company. You're seeking product market fit. This is going to be going from product team. Whichever product is moving the fastest, you're going to ship them there. You hit product market fit. Okay, this changes slightly. Maybe there is an early product that needs to shape up. You ship them there. You are post product market fit. You're focused on scaling. You're focused on consistency. You might want to go to the central teams. You might want to go to the platform team, the DevX team, the reliability team, and embed your people there so that security is just part of what they're shipping. And it's core to what they're shipping. And the other way to think about always seek the highest leverage is you don't want to carry maintenance load for these things that you're building. The reason we're exiting is because we're finding a clean handoff every single time. We're saying, hey, we're building this, but you're going to maintain this. Now, there's going to be exceptions here. And the exception could be you are building something that you're truly the expert at. Maybe you need to build a key management service. Maybe you need to build an encryption service. You're truly the expert at it, and it needs to happen. Make sure you go through your SDLC process, by the way, as you do it, but maybe you need to do it, and that's fine. It's okay to have to build this critical service. The important thing now is to find the lines of separation. In other words, if you're building an encryption service that a bunch of products are going to use, come up with an interface where they're responsible for reliability or for load, for scaling, things that are not security problems, things that product teams are going to be competent at doing. But you're still on call if encryption breaks. You're still on call if something weird happens and they can't decrypt it anymore. If your key management system is just refusing to serve up keys, you're still on call for that. But basic reliability stuff, you need to be able to abstract that and hand it over to others. This is something I learned the hard way, which is you want to constantly validate your assumptions. When you operate in this mode, you're actually getting stuff done. You're reducing security risk. You're moving at a really high velocity. You're keeping up with the company. And it feels great, but it can also lull you into a false sense of security because you're moving faster than you ever did. You're moving at a velocity that's so great that you forget that things are still going to break. And this is where you need a red team. You need a bug bounty. You need internal and external assessments. And you need them to when you have a red team, constantly give them new objectives. Constantly get them to find things that you think you have a blind spot in. They're going to find it. And same thing with the bug bounty. They're going to find things that you missed. It's hard to get 100% coverage. The goal is to keep up as much as possible. So always be clear-eyed, have a sense of where your attack surfaces are, what your risks are, what your mitigations are, what you're going to miss, even as you're moving at this pace. Stay lean. I can't say this enough. Leverage is what makes this work. If you become too big, you end up having a lot of coordination overhead, and you can't move fast. You can't have this velocity. You can't have this stellar team. Manage risk, build trust. If you have these people going and deploying, fixing things, working with partners, that's going to build trust. That's going to help you know what the biggest problems are. That's going to help you manage risk. Along the way, maybe you profit a little bit. Now, I said a bunch of things about hiring stellar people and finding software engineers and production systems, but real talk, hiring is hard. I had my struggles hiring the best people to do these things, and I've been really fortunate. I've had good funding, I've had good headcount, I've had good budgets. I've been able to go and find distinguished engineers and principal engineers and staff engineers and just stack the team. But it's hard. And every company's needs are different. Every team looks different. So start small, be iterative, have a high bar. And make sure you stay at that bar even when you're not able to find people that meet the bar, because I promise you, you will find them. You just have to figure out your pipelines, you have to figure out your interview loop, all of that, but you will find them. They exist. Learn your lessons along the way, challenge your assumptions, and build the right team. And that right team for you might look very differently to the right team for me. And while you build this, and this is the LLM part of the talk, LLMs can help better bridge the gap. Now, I work for OpenAI, and this isn't about using OpenAI. This is about using any LLMs that you want, because they are capable, they are powerful, they are a tool that can help defense teams. And we use them internally. Now, there's a lot of FUD associated with the use of LLMs. There's a lot of, I don't have to go into it, and I won't go into it. There's a lot about how adversaries can be more effective with them. There's a lot about how LLMs are insecure or not insecure. I'm not going to go into the veracity of these things. You can validate them for yourself. You can read about them for yourself. But I'll bring it back to system design. You can't advise on something if you don't understand the edges of the system that you're working with. Your teams, your partners, they're going to want to use LLMs. They're going to want to use AI for the things that they're doing. They simplify so many flows. And the fastest path to it, to understanding how it works, yeah, there's plenty of YouTube videos. Andrej Karpathy has this 2-hour thing that he explains how GPTs work. There's Caleb Sima put out a whole thing about LLMs and security. You should go read all of those things. It's amazing. I learned by doing. Use it to solve some of your problems, like we did. We launched a bug bounty a few months ago on BugRoute. We happened to be a little bit popular, so we got a lot of reports. And we were still a small team, and we couldn't go through all of the reports in a reasonable amount of time. So we said, hey, you know who's good at reading English or like languages in general and going through reports? GPT-4. So we're going to set GPT-4 on it. But we're going to use it as a classifier, not as an analyzer or responder, just a classifier. It's just going to tell us, is this out of scope? Is this an AppSec issue? Is this a dangling domain? What is the problem here? And it just said, hey, this is the problem. You need to go solve it. Great. And that helps us keep the validation time frame within 24 hours, which is pretty great. We still need humans in the loop. If the bot hasn't closed something, we still need to go in, we still need to validate, we still need to triage. But it reduces the time when initially it was a couple of days. Now it's under a day, which is pretty great. Access management, I'm sure everyone here, there's a bunch of talks today about this. I'm excited to see them. People want to access things, they get weird errors. And they say, hey, I don't know what it is. And they'll come and ask your security channel. We built a thing where they just paste their error into this tab, and we just go do a bunch of lookups and GPT-4 says, maybe you want this. Other people that are requesting for this usually ask for this. Other people that see this error usually get this group. Humans still need to approve the access, they still need to review, but it helps us keep the number of groups or amount of access that people have small, because we don't give the largest group to unblock someone. We give them exactly the thing they need, and that's hugely helpful. We have a security channel, like many of you do, and we get a lot of questions to it. People are saying, hey, I need to do X. I don't understand how to do Y. I have a question about why this piece of code is doing what it does. And before, we had a human going through it, triaging it, sending it to the right people. Now we have a bot looking at it and still sending it to the right people. It just classifies and says, this seems to be a problem for my team, product and platform. This seems to be an incident response issue. This seems to be an IT issue. It just routes accordingly. We use it for SDLC. Somebody wants to build something new, and they want to get it on our radar. And before, the bottleneck is a human that's reviewing these documents and just glancing through them and trying to do a gut check of, is this important, is this not important? Now, with some work, built a bot that does the same thing. It goes through a Google Doc, it asks you a bunch of clarifying questions, and it tells you, is this something that needs to review before launching? Is this something you can launch and we'll take a look later? Is this something that should be backlogged? It's great. It streamlines the process really fast, and it makes teams feel like they're unblocked. We also use this for incident response, where something triggers an alert. I created a file, shared it publicly, and that triggered an alert. Now it's 3 a.m. You don't really want to wake up your on-call. The bot comes in and says, hi, did you mean to do this? Is this something that you intended to do? If you say, oh, sorry, I didn't mean to, I'll fix it. It goes away. It's like, got it, you're fixed. I'm not going to wake up anyone. If you say, I have no idea what you're talking about, I didn't do this, it'll ask you a bunch of clarifying questions, and eventually it pages the on-call and says, something's wrong here, you should look at it. There's a bunch of vendors that are doing really good work here for defense too. When I was making this presentation and I was Googling LLMs and security, there's a bunch of offensive security work there, but there's some really, really cool defensive security work. Sockets using it for analyzing open source dependencies, SemGrep's fixing false positives and putting patches in. Material, Ryan Noon and co. built really cool ways to detect incoming spoofing emails, spam, phishing emails using GPT-4, and really effectively build it better than existing systems. This is not an endorsement to use these companies. They're just doing good work, and I thought I would mention that. LLMs can really create a ton of leverage for you as defense teams. But like with any other system, you gotta use care while building with them. You're operating with untrusted inputs sometimes, and that can be risky, like with any other system. Constrain your outputs, use humans in the loop, purpose build your systems, and maybe along the way, consider using system design to do this. I sincerely believe that effective security teams can create business value, not just preserve, not just protect, but create. And we can help businesses move faster, more securely with the right security teams, with the appropriately leveraged security teams. And using system design to build this leverage, it helps us identify what we need to do and how we need to build. That's all I have. Thank you, everyone.